Hi, Assalamualaikum warahmatullahi wabarakatuh. Well, in this video, we are going to look at some examples just to test your understanding about function. Okay, so we're going to start off with this example here where you have a function f which is defined as 4x minus 8. X here is the input. Okay, so x it consists of all real numbers. So real numbers means any value from negative infinity to infinity. So that is the definition of real numbers. And this is actually a domain. To be specific, this is the domain of that particular function. So the first question is to find the value of f3. So what is f3? So f3 it can be obtained by substituting 3 into this function. So we have 4 times 3 minus 8. So we have 12 minus 8, which is equal to 4. Okay. All right, next the value of x. What is the value of x if its image is equal to 32? So when you talk about image, you're talking about fx. Fx is equal to 32. So fx is equal to 32. So what is the value of x? So let's start off with that. Fx is equal to 32. So what is fx? What is this function? The function here is 4x minus 8. So we're going to substitute that into this. So we have 4x minus 8 is equal to 32. So 4x is equal to 40. X must be equal to 10. So when you plug in the value of 10 into this function, then you will get the image equal to 32. And finally, what is the value of x such that or until fx is equal to x? So here we have fx must be equal to x. So what is this function? This function is 4x minus 8. So we're going to substitute that into it. So we get x. Next, you will be able to get that 3x is equal to 8, and finally x is equal to 8 over 3. Okay, so this is just a simple example to illustrate the idea of a function or the process involved in function. Okay, next, given these two functions here, determine the domain and range of the function given below. So again, let us recall what is the definition of a domain. Domain is the set of all possible values, which means the values that this function can take, all the values of x such that this function is going to be working just fine. So that's the idea. Okay, and based on this, we can see that if I plug in whatever value of x such that x is a real number, then you don't have any issue or no problem whatsoever. Okay, so for question A, fx is 2x minus 1, and I can see that my domain will be real number. Okay, it's a set of real number. I can write down in terms of this notation, which is x, where x is the real number, or I can write down in terms of mathematical notation, where I can write it down as, okay, x is the element of real number set. Okay, so that is the domain, and you can also see that the codomain will also be the same thing. So codomain will be equal to y, where y is also going to be real numbers. Okay, now for question B. We have this function fx is equal to x squared, and I hope that you can see the domain is also real numbers. So x is going to be real numbers. You can plug in whatever values of x from negative infinity to infinity. It works just fine. Okay, and based on that, you can see that the codomain of x is the codomain is going to be y, where y is going to be a value which is greater than or equal to 0. Okay, now if you think that it's difficult to come up with this idea or these answers, what you can do is you can try to sketch the graph of this function so that it gives you the idea of what the answers could possibly be. So if you try to sketch this graph, it is just a straight line. Okay, so this is x and this is y. So the intercept at -1, and we know that it's going, the slope is positive here, so we know that it's going in this direction. So you can see that the domain is the values of x. Okay, again, domain is the values of x. You're talking about this axis. So you can see that it can go on and on and on. So it goes from negative infinity in this direction to positive infinity. So that's why x, the domain here, is all the real number. And the codomain is also similar. You can see that if you extend this line function, you can see that for y, it can goes up to positive infinity. It can also goes down to negative infinity, and therefore the codomain here is also consist of all real numbers. Now for this function here, this is a simple quadratic function, and it's going to look like this. Okay, so this is x, this is y, and as you can see, for domain here, you are going to consider the values of x. So x can goes in this direction. Okay, it can go in this direction as well. So x can take any real numbers. So this is the domain. However, for the codomain, you can see that the graph, the lowest number is at 0. So y, the lowest value for y is 0, and it can goes up to positive infinity. So therefore, the codomain here is y greater than or equal to 0. Okay, so whenever you find that yourself stuck in answering this type of questions, then you can always start thinking or sketching the graph, and perhaps you can come up with the correct answers. Okay, finally, this is the last example. Determine whether the given graph here is a function or not a function. So this is a basic, so this is an example to test whether you understand the basic idea of a function. So what is a function? We have said before that a function is a special types of relation which is either one-to-one or many-to-one. So this is what you have covered in the previous video. Now you can see clearly that for this one, if this is my x, this is the value of x, my x is mapped to exactly this point. So this is the value of y. So similarly, if this is my x, I'm sorry, then it is mapped to this value of y here. So one element to one element, to one element. So this is an example of a function. So this is a one-to-one relationship. Okay, for this one, you can see that if this is my x, or it will be mapped to either this point or that point. So clearly this is not a function, because it needs to be mapped to exactly one element. Okay, so the value of y, so y here needs to be only one value. So x needs to be mapped to one value of y only, cannot be two values. So similarly for this one, if this is my x, you can see that x will be mapped to either this one or this one. So therefore this is also not a function. Now we can easily decide whether this is a function or not by doing a vertical line test. We call this vertical line test. So if you draw a vertical line, if it touches more than 2 points, that means it is not a function. Okay, so if you draw the vertical line here, it touches more than 1 point, then that is not a function. You can draw it anywhere on the graph, so it touches 2 points, not a function. For this one, you can see that it only touched 1 point. At this point, it only touched 1 point. It only touched 1 point, so this is a function. Alright, I think that's all for now. Thank you very much for watching.